Hi, good morning everyone. Today we are going to discuss about atoms. The matter is made up of atoms. To explain the structure of atom, various atomic models were proposed. The important atomic models are Thomson atomic model or else plum pudding model, Rutherford atom model, it also called planetary model, Bohr's atom model, Bohr's Sommerfeld atom model, vector atom model, wave mechanical atom model. Have a look at these different types of atomic models were proposed by different scientists. First, let us go for Thomson atom model, the other name plum pudding model. This is the first model proposed by J.J. Thomson. According to Thomson, atom model consists of the positive charge of an atom is uniformly distributed throughout the volume of an atom. The negatively charged particles called electrons are embedded in it like seeds in a watermelon. Therefore, this model is also called plum pudding model. Some drawbacks are there for this model. Have a look. This model fails to explain alpha particle scattering experiment. So what is alpha scattering experiment? Have a look at this. So Geiger and Marsden, those are the two scientists. They have constructed a schematic arrangement to experimentally show the alpha scattering. So looking at the diagram, they considered source of alpha particles and lead bricks and the gold foil, which a very thin gold foil is around 10 power minus 8 meter thick, and they used a detector that's a microscope, electroscope or also called microscope. It can be a rotatable 360-degree. So what they observed in the experiment, Geiger and Marsden did the experiment under the suggestion of Rutherford. The alpha particles emitted by bismuth 214, it's a radioactive sample, are collimated into a narrow beam by passing through a passage of lead bricks. A narrow beam of alpha particles are made to incident on a thin gold foil of thickness 2.1 into 10 raise minus 7 meter. There they observe alpha particles will scatter in different directions. The scattered alpha particles are detected by the rotatable detector. So some of the observations regarding the alpha scattering experiment. Maximum number of incident alpha particles pass through gold foil without deflection. Notice the point, without deflection means without scattered, because there is no collision. But you not collision between alpha particle and the gold nucleus. And the second observation they noticed, only 0.14% of incident alpha particles scattered by an angle 1 degree, more than 1 degree. And the third observation, about 1 in 8,000 incident alpha particles, I'm stressing again, 1 in 8,000 incident alpha particles deflected or scattered by an angle more than 90 degree. And the fourth one, only small fraction number of incident alpha particles rebound back, means they have scattered through an angle 180 degree, undergoing head-on collision with the nucleus. Which nucleus? Gold nucleus. Gold nucleus. Yes. So these are the four important observations regarding the alpha scattering experiment, which was conducted by Rutherford and experimentally arrangement given by Geiger and Marsden. So now some conclusions regarding the alpha scattering experiment. Most of the alpha particle passes through foil undeflected. Most of the alpha particles means space of an atom having empty space. Most of the space in an atom is empty. The second observation or conclusion, few positively charged alpha particles were deflected. Only few. You observed in the experimental observations 0.14%. Third conclusion, positive charge is concentrated in a very small volume that repelled and deflect the positive charge particles, that is alpha particles. The fourth one, conclusions by Rutherford showed that volume occupied by the nucleus is negligibly small as compared to the total volume of the atom. The radius of the atom is about 10 power minus 15 meter, while that of nucleus is 10 power minus 15 meter. By gathering these informations, Rutherford proposed his atomic model. What his model says, have a look. Almost all the mass of an atom and entire positive charge of an atom is concentrated at the center. The central part is called nucleus. The negatively charged electrons are revolving around the nucleus just like planets around the sun. This is the first information regarding the atom given by Rutherford. And he also mentioned the size of a nucleus is about 10 power minus 15 meter to 10 power minus 14 meter. And then the size of an atom was known to be 10 power minus 10 meter, about 10,000 to 1 lakh times larger than the size of nucleus. Thus, most of an atom is empty space. You got the idea why most number of alpha particles have been passes through the gold foil? Because there is an empty space. Hence, those alpha particles will pass through the gold foil without any scattering. And the fourth one, electrons and the nucleus are held together by electrostatic force of attraction between nucleus and electrons. These are the some informations regarding the Rutherford atomic model. Now, let's have a look how much force between the alpha particle, electrostatic force of repulsion between the alpha particle and the positively charged nucleus is given by. We have that formula 1 by 4 pi epsilon naught 2e, that is the charge of an alpha, Ze is the charge of nucleus, and r square, that is the distance between alpha particle and the nucleus. Look at the diagram how alpha particles have been passes through. Most of the alpha particles are passing undeflectedly. A few 0.14% of alpha particles have been scattered with an angle 1 degree, and very few alpha particles have been retraced, that means scattered by an angle 180 degree. That is, trajectory traced by an alpha particle depends on the impact parameter of the collision. What do you mean by impact parameter? So impact parameters. The perpendicular distance between the initial velocity vector and the alpha particles and the center of the nucleus is called impact parameters. In the previous diagram, you have noticed there is a perpendicular distance which is represented by b. See, regarding the impact parameters, there are some important notes. B is necessarily equal to 0, then scattering angle is 180 degree. Means the initial velocity vector of alpha particle and the final is 180 degree. When it is rebound back or retraces its path. If B is very large, then theta equals 0. Those alpha particles passes through undeflections. They have a greater impact parameter. Hence, impact parameter is inversely proportional to scattering angle. And the one more quantity which we have to define while studying the alpha scattering, that is the distance of closest approach. It is the center to center distance between alpha particle and the gold nucleus when the alpha particle is at its stopping point. What is the stopping point? We have noticed only few alpha particles will retrace its path, means their scattering angle is 180 degree. That's also called head-on collision. While the alpha particle approaching the nucleus, it is coming towards the nucleus, means nucleus is positive charge, alpha is also positive charge. There is a strong repulsion between two positive charges. Hence, it will approach a minimum distance and then it retraces. That is what the distance of closest approach. Have a look at the formula for distance of closest approach. D equals 2 ZE square divided by 4 pi epsilon naught K.